Welcome to episode 12 of our ComfyUI tutorial series. Today I want to show you how I upscale images to get a larger size and better quality. Usually when you upscale an image, you lose quality, but with ComfyUI, we can actually achieve a bigger image with improved quality. I searched for a method that upscales quickly while still maintaining good image quality. Let's go to the Manager and Custom Nodes Manager to get the custom nodes we need for our workflow. If I sort by installed, you can see all 10 nodes I have from previous episodes. Now, let's change the filter to all and search for Control-Alt-AI nodes. Click Install, and once it's ready, you'll see a Restart button. However, I don't want to install it right now, so I'll click Cancel. On the right, I see there are some new updates for ComfyUI, so I'll choose Update All. This may take a while until it updates ComfyUI and the nodes, and then you can restart. With one move, we'll have our new installed node and all the updates. Go back to the manager and this time choose Model Manager. From here, you can install all kinds of models, so let's filter them by choosing Upscale. You can install one or more models. I'll install Siax, which is a good general use model. Anime Sharp, which is great for anime, vector, and clean graphics, and maybe foolhardy. And this time, Comfy doesn't need a restart, only refresh. Click refresh, and it will be available in your interface when you add the custom nodes. Let's load a workflow. I've saved several workflows for you on Discord, so you can simply load them. If you have a good video card that can run Flux, you'll get the best quality. It might look complicated, but I'll explain each part later. Let me quickly show you how it works. I'm using the Flux Dev Guf Q8 version with clip models, just like we used in episode 10. I've added some instructions in this note. To start, upload an image. I'll choose this portrait, then describe the image. You could use a single word like masterpiece, but you'll get better results with a more detailed description. Flux prefers long prompts, but for this example, I'll keep it brief. What I did was scale the image down to a manageable size, then upscale it using a model to add some sharpness. Essentially, this is an image-to-image process with extra steps and settings to improve the quality. After that, the image is saved and then upscaled once more using the model. The final upscale is saved as well. If you notice, I've found that these settings work best with Flux compared to SDXL, which needs different values. Don't go over 95. The generation is complete, and we have the first and second upscales. It's hard to compare them side by side, which is why I added an image comparer node. As you can see, the images that started with lower quality now have a lot of nice detail. If the image is too blurred, details might not be recoverable, or it could be over-sharpened. But this method is great for images typically generated with AI. After a few days of testing with Ultimate SD Upscaler and ControlNet, this was the fastest solution for me that provides more detail in the image, large enough for my needs. I hope it helps you too. I uploaded a second image, which is a 3D render of a building. I'm adding a quick prompt to help the AI identify some of the objects in the image. If you have the original prompt for your image, that's even better. It took me 46 seconds to upscale this image using an RTX 4090. The first generation always takes longer because it loads the models. Let's compare the images. The first time I got the settings right, I was surprised by the amount of detail Flux can add. For example, look at the leaves and grass and the clear water. If you want to give the AI even more freedom to be creative, you can increase the denoise value, but don't go over 95. Let's give it a quick test. Now, observe how the rocks are different and how some flowers were added to the grass. In this seed, almost everything was accurate except for the bed, which I didn't mention in the prompt. I only mentioned a car, so the AI tried to create a car instead. If I open the first upscale image, it has 14,008 pixels. I use values for sizes that are divisible by 64 to achieve better quality. The second image is 2816 pixels, which is sufficient for what I usually need. However, you can always make it larger if you want. You can see the values for the last node before saving. I'm using a 4x upscale model. So the value 1 means it is upscaled 4 times. That's why I used 0.5 to upscale only 2 times. If I change it to 1 and run it again, I'll get a much larger image, over 5,000 pixels. This size is useful for print and other applications where you need a big image. There is a way to get an even larger image, but it requires a lot of VRAM. I scaled down the image here to 704 pixels. If you change it to 1024 pixels and run it again, it will take 3 times longer on my PC, as you can see. But now we have more details in the image, such as the leaves and plants and the texture on the building. If I open the first upscale image, it has 2048 pixels, which is already enough for most uses without the second upscale. The second upscaled image is huge, over 8,000 pixels. I'm usually satisfied with the first upscale and don't need the second one, but you can delete the last nodes if you don't need them or simply bypass them. I'll reset the values to default, and then we'll go into more details and take it step by step to understand how it works better. Click on the clear button so we can start with a clean canvas. Double click and search for a node called upscale image using model. Add it, and as you can see, it has some inputs. Drag from upscale model input and upscale model loader. This node will let us load a model. Remember those models we installed earlier? If you download one from the internet, you can also place it in the models folder. Look for the upscale models folder. I will select a model like Siax model. Next, we need an image, so let's add a load image node. From here, you can upload your own image. I'll choose this portrait. We now have the upscale model and the image, which both go into the upscale image node. To save the result, add a save image node. This way, the image is upscaled and then saved. Let's run the workflow. As you can see, it's working, and in a few seconds, I have a larger image. If I open the original image, it has 1024 pixels, which is a common size with AI. The upscaled image, however, has 4,096 pixels, which is 4 times larger. This is because the model is labeled 4x, meaning it upscales 4 times. Sometimes 4 times might be too much for complex workflows. So let's see how to make it smaller, like a 2 times upscale. Search for a node called upscale image by and add it to the canvas. Connect the image inputs and outputs. For the upscale method, many options are similar. I'm choosing a Lanczos, which is popular. Instead of using one for the full power of the model, I'll select 0.5, which upscales only 2 times. Running the workflow with this setting will give you an image that is 2048 pixels. To compare 2 images side by side, search for a node called Image Comparer from the RG3 node pack. Add this node to compare the original image and the upscaled image. Run the workflow and enlarge the Image Comparer node. You can compare the images by moving the mouse left and right, which, as you can see, the image is sharper and clearer and also 2 times larger. This solution is quick if you just want larger images. Let's test it with a vector style cat. The result is quite nice, but we can do even better. Siax is effective, but you should choose your model based on the image you're using. I'll quickly duplicate the workflow and choose the Anime Sharp model. For the second workflow, this model is better for vectors, logos, and clean designs. Add a new image compare node to compare the 2 workflows. Connect the first workflow to the first input and the second workflow to the second input. The first is the Siax model, good for all kinds of images, and the second is the anime model, which is better for simple, clean designs. Run the workflow and test it. When the mouse is on the left, you see the Siax model. On the right, the anime model upscale. Although the recording might not capture it clearly, on my screen, the anime model provides sharper and clearer edges, while the Siax model adds a slight glow that isn't ideal for vector images. This was a simple upscale, so next let's implement a more creative upscale to generate a clearer variation of our image. Let's load a simple text-to-image Flux workflow, the GUF version from episode 10. To have more control over the image size we generate, let's add a custom node called Flux Resolution Calculator. You'll see that the empty image has two inputs for width and height. However, we can't connect new nodes to these inputs directly, so we need to convert them. By using the write and convert widgets, we can turn these values into inputs for both width and height. Now we can connect to the Flux Resolution Calculator. I'll change the color to purple to indicate that they are in the same category. What makes this node special is that it automatically calculates the best resolution for Flux based on megapixels and aspect ratio. For example, I can choose 1 megapixel, and for aspect ratio, there are many pre-made options to make it easy to use. As you can see, if we generate, we get that resolution. We can test various resolutions like the cinematic ultra-wide. The final image is decoded and ready in the VAE decode node. We also have a node to save that image. However, we can continue the workflow further. From the VAE decode node, we can add more nodes to process, modify, or upscale the image. Let's add a node called upscale image by. You can choose your preferred upscaling method, and for scale by, you can select how many times to upscale, such as 2, 4, or any value you need. I'll choose 2. Now, connect the image input and output from the V8 decode node. Next, add another node to save the image. Let's change the aspect ratio to square and run the workflow. We now have 2 images generated. One is the original and the other is upscaled by a factor of 2. You can see that the original image has 1024 pixels, and the upscaled image, which has been doubled, now has 2048 pixels. The upscale image node doesn't improve the image much, and I want it to be sharper. We can upscale using a model like we did a few minutes ago. So I'm adding a node called upscale image using model. Next, we need a model. So let's add another node called upscale model loader. For the model name, I'll choose Siax. We now have the image saved right after generation, and we also connect it to the upscale image node. There, the image is upscaled using that model. As you can see, the Siax model starts with a 4x, meaning it will upscale the image 4 times. Then we need to save the image, so I'll connect it to the save image node. Now we can run the workflow, and the result is a 4096 pixel upscaled image. But what if we need to control how much the image is upscaled? If we add more nodes, working with such large images can be difficult. So let's add the upscale image by node again. Choose your upscaling method, and since we are using a model, if we set it to 2, it will upscale the image 8 times because the model's default setting is 4 times. To get a 2x upscale, I'll use 0.5. Connect the nodes so the image is saved after being upscaled 2 times. Let's arrange it a bit so it's clearer. Now the image is generated. After that is using the Siax model to upscale it, and we control the amount of upscaling using the upscale image by node. I'll change the colors to yellow to make it clear that they are part of the same category. Let's test the workflow. The result is an image upscaled 2 times, which is slightly sharper than the previous method we used without a model. Can we expand the workflow even more? Yes, we can. Let's add a K-sampler node. This is the node we use in both text-to-image and image-to-image generations, so you should be familiar with it by now. We generally want almost the same settings as before. You could copy and paste. I prefer connecting things manually to learn. In the process, we have this model input here, so we need to connect it to the model output from where we loaded our Flux model. That was easy. Now we have positive and negative inputs. Connect these as well. Connect the positive prompt to the conditioning. Sometimes when the negative node is collapsed, you can't connect directly. So click the gray dot or right click and choose collapse. Then you can drag the connection. Alternatively, you can drag the connection from the K-sampler node first and then connect it. That way it works. We have one last input to connect. We could connect the latent input between the K-sampler nodes, but that would skip our upscale nodes and use latent instead. Alternatively, we could encode the image back into latent after it's decoded in the VAE decode node. But again, I want the upscaling to happen first. So after the image is upscaled, right after the upscale by node, we encode it using the VAE encode node. Now we can connect the latent input and output. This way, the image is upscaled, then encoded and sent to the K-sampler. But how do we decode it back to pixel format? We use a VAE decode node again. After decoding, we can add a save node to save the image to our computer. All the VAE encode and decode nodes need a VAE file. For some models, this is included in the model, so you can connect to the VAE in the load checkpoint node. In this case, the VAE is separate and needs to be loaded using the load VAE decode node. Let's connect one. If you forget to connect a node, don't worry, you'll be notified. You'll see a little red circle indicating a missing connection. Connect that as well and check what settings we can adjust. For Flux, we need the CFG to be set to 1 because when it is set to 1, it ignores the negative prompt. This is necessary because negative prompts are not supported with Flux. Now, for samplers and schedulers, you can experiment to find what works best for you. For image-to-image tasks, I usually use DPM plus 2M with Keras. But Mateo has added some tests in a recent video on the Latent Vision YouTube channel, so you can check that out. Like any image-to-image process, we get our image after generation and then pass it to the K-sampler. We need to lower the denoise value, but I will show you what happens if we leave it at 1. So basically, we unlock the 4th dimensions. Yeah, I can make my AI voice to laugh. Pretty cool, isn't it? Or should I say, cool? So usually with models like SDXL, if we use values like 0.5 for denoise in image-to-image tasks, we already start to see some changes. But for Flux, the values are higher. I've noticed that values between 0.8 and 0.95 work well. Well, so I'll go with 0.85 for this one. The image entering the K-sampler is quite large at 2048 pixels, which makes it a big size to process. And it took over 100 seconds. The resulting image will be the same size, but with changes depending on your settings. This might crash some computers if the image is too large. So going back to the Flux calculator, the solution is to lower the resolution with a value of 0.5. Now, the initial generation is small at only 704 pixels, which makes the workflow much faster. Flux can generate good images even at this resolution. After that, the image is upscaled twice, resulting in a nice 14 by 8 pixel image. Running this image through the K-sampler, again, is more manageable. If your PC can handle image-to-image generation at this size, this workflow should work well for you. The final image has much more detail than the first generation. It has the same size as the upscaled version, but is clearer with extra details. I'll delete the save node that shows only the upscaling and keep only the 2 save nodes, one for the initial small generation and one for the larger second generation. Now we can use an upscale model to get a bigger image. Since the current image has more details, the upscaled image with the model will look better compared to a small image that's upscaled. Let's copy the upscale image using model and upscale image by nodes. Connect the result of the second generation to the upscale image using model node. So it gets upscaled 2 times. If you use 1 instead of 0.5, it will upscale 4 times. Add another save image node to save this image to your computer. If you don't want to save some steps, you can use a preview image node instead of a save image node. For the model, you can either connect another load upscale model node if you want a different upscaler for the last step, or you can connect to the existing node. Running the workflow will give you 3 images: the first small generation, the second generation that is doubled, and the third, an upscaled image that is doubled again. The final image is 2816 pixels, big enough for most AI uses. To compare, let's add an image comparer node, connect the first generated image to the image A input, and the last upscaled image to the image B input. Add another image comparer node to compare the second generation with the last upscaled image to see how the last step influences the result. Running the workflow, you'll see that the first generated image compared with the final image is now sharp, clear, and has a lot more details. It's like switching from HD to full HD or 4K. Comparing the second generation with the final upscaled image shows not only that it's double in size, but also that it's more sharpened. If it's too sharp for your taste, you can reduce that in post-processing or use different upscaling models that don't add as much sharpening, which can sometimes be a problem for faces. As I mentioned, I saved a lot of versions on Discord for different models with instructions, so let's load this example. I included a README note that can help you get the extra nodes and models, so check that out first. For resolution, I suggest playing with the ratio unless you have a lot of VRAM. Then you can try one for megapixels. Experiment with Flux guidance and try different samplers and schedulers to find what works best for the type of images you create. Choose your upscale model. By default, it's set to the Siax model. For the second sampler, I recommend values between 0.80 and 0.95. Anything above 0.96 will start to go into a different dimension. For the final upscaler, you can use 0.5 or 1, depending on how large you need the image to be. That's it. Now, let's add a prompt I generated with ChatGPT to see what it can do. We'll go with a panorama ratio and hit the Q prompt button. This workflow saves 3 images: the first generation, the second that is upscaled, and the third, which we'll call ultra upscale. What I like to do is check the preview of the first generation. If I'm not satisfied with what it generated, I can click the View Queue button to see the current workflow running. If you press the Q button multiple times, you'll see more jobs running here. Clicking Cancel will stop the job within a few seconds, and you can hit Q prompt again. I review the first generation. If I like it, I let the workflow continue. If not, I click Cancel. Let's try it one more time. This time, I'll let it run so I get the second generation, which is upscaled. If you wait a little longer, the third generation will be ready soon. Usually the second generation takes the longest time. Now, let's open the final image, the ultra upscale version, and check out the details. From a distance. It looks almost real. If you posted something like this on social media, it would likely pass as real to most people who don't work with AI. I'm really impressed with what Flux can generate. Let's try another prompt for a landscape image. From the first generation, I can already see it had nice composition and color, so I'll let it run. The second generation, which I can preview, shows more details, and the third one is ready now. So let's check how it looks at a larger size. I really like the details in the grass. I've always struggled with SDXL models to get good details in leaves and grass, but this looks impressive. I also tested it with a coloring book page. Sometimes those with a white background can get blurry. You can try increasing the steps to 30 or 35 to see if that helps. The result is quite nice and clean. I used the Anime Sharp upscale model for this one. The resulting image is quite large, as you can see. Let's load another workflow, for example, one for SDXL. I use the Juggernaut X model for this workflow. You can get it from Civit AI, or you can use another SDXL model. Just adjust the settings in the case sampler to match the model. The denoise range is different compared to Flux. For SDXL, we need values between 0.2 and 0.4 to get something similar with acceptable quality. If I run it, this is the result. This workflow generates an image and then upscales it. So with a single run, you can get a large image. I also created some low VRAM versions with smaller models like SDXL Hyper and SD version 1.5. Let's open this SDXL Hyper text-to-image workflow with an upscaler. You'll notice that the VAE decode and encode nodes have tiled in their names. At the time of this recording, it's marked as beta, so you might need to update Comfy to see these options. This version has a tile size setting. If you don't have enough VRAM, you can use 512 pixels for a tile to save VRAM and avoid freezing. If you have more VRAM, you can increase it to 1024 pixels, which should make it a bit faster. The generation and upscaling are quite fast and provide acceptable quality for SDXL Hyper, not as good as Flux, but suitable for low memory use. Let's try one for the SD 1.5 version. I'm using Juggernaut Reborn, but if you use a different model, you can adjust the settings accordingly. The denoise values allow you to control how different the result is from the first generation, and we get our 3 images. Let's open the last one. The details are quite good for an SD model with some nice textures. It's fast and free with the final image size at 28 by 16 pixels. You also have the image-to-image version where we upscale our image creatively. If I add a portrait of a woman and provide a quick prompt to describe the image, I get something like this when I run it and compare it. It recovers some hair and skin textures, so for something that quick, it's not bad. Play with the settings to see if you can improve it further. You also have a simple upscaler for when you need to quickly upscale an image without adding extra details. Choose your photo, then select your upscale model, adjust the scale based on the model you're using. When I run it, I get this image in just a few seconds. You can use the image comparer to see how it looked before and after. It makes the image clearer, sharper, and of course, larger. If you're not interested in comparing and just want to upscale, you can delete the last node with the comparer as well as the note and labels if you prefer. This leaves you with a small workflow of just 2 nodes that you can save using the Save button. For example, testing it on a vector style cat with an Anime Sharp model, it only took a few seconds and the image upscaled well for that speed. Of course, you can also use the upscale by node to make it 4 times larger since we're using a 4x upscaler model. I also created a compact version of the image-to-image upscaler with Flux, making it easier to fit everything on the screen. Let's choose a landscape photo since it has many details that are often challenging to capture. You can describe the image. For this test, I'll use just a few words, but you can add longer prompts depending on the denoise value. Hit generate and then compare the before and after upscaling. Let me zoom in. As you can see in the trees, the details really start to come alive with all those leaves. It's like putting on a pair of glasses and suddenly seeing everything clearly. The details in the house, the foreground, the grass, and the flowers are all enhanced. What do you think? I also tried it on an anime image using the Anime Sharp upscale model and a few words in the prompt. Comparing before and after, you can see that the image is now much clearer and sharper. For me, that's good enough. Let's test it on a line art illustration as well. Once again, the image is sharp. In my opinion, among all the models with Flux, I'm getting the best results for upscaling. I wish I had more time to test with all possible settings, but for now, it's good enough for me, and I hope it will help some of you with upscaling as well. The goal was to get a bigger image quickly. I don't like to wait minutes for a larger image, and with my RTX 4090, it takes under a minute, even if I generate and then upscale. A special thank you to the Legends members who have been crucial in testing these upscalers on Discord. Your support is invaluable. I also want to thank everyone who supports my channel and those who have joined my YouTube membership. If you found this video useful, please leave a like or a comment. Have a fantastic day.